Good afternoon, students. I welcome you all for this session of heat transfer. In the previous session, we have discussed about the extended surfaces called as fins, where we could learn about how important a fin is, and we also learned about how it is helpful in enhancing the rate of heat transfer from a given hot body. We discussed with an example called as IC engine, where I told you how does it help in increasing the rate of heat transfer using the fins. Likewise, in many other applications, we do find the usage of fins. They in particular are being meant for increasing the rate of heat transfer from a given hot body. Now, today in this session, we will discuss about the various configurations of the fins, and later we will analyze an uniform cross-sectional fin, where we will understand how the heat transfer occurs through the given fin, as well as we will also try to learn how is the distribution of temperature across the length of the fin. Okay, at first let us have a look at the various configurations of the fins. Basically, we come across the different configurations, namely in the figure I have shown you around 4 different configurations of fins. If you can see in all the diagrams, this one and this one, the hatched portion what I have shown, they all are nothing but they all are the base surfaces. So as I already mentioned, so base surface is in fact it is a hot body. Okay, base surface is a hot body. Now from that we want to increase the rate of heat transfer to the surrounding air. So for that we come across the usage of different fins. You can see in these diagrams. So if you look at this, these all are called as different configurations of the fins. Okay, take a look at this first one. First configuration, figure number 1, you can see. So there is a base surface. To that there is a rectangular fin. What is its cross-sectional area? You can see this, it's a uniform cross-sectional area. That's why it is said straight rectangular fin of uniform cross-section. So here the area of the fin is uniform throughout its length. And how is the cross-section? It is a rectangle. Hence the fin is called as rectangular uniform cross-section fin. Okay, so the heat transfers from the base surface through the length of this fin, then from this fin to the ambient convection heat transfer occurs. Thereby the total rate of heat transfer from the base surface to the air will be increased. Okay, so that is one kind of configuration. Now moving on, the second configuration, you can see in this, in comparison with the first one, you can see that again it is a fin. Okay, it is an extended surface from this base surface. Okay, so here if you notice, the area of the fin is not uniform. You can take a look at this. At the base the area of the fin is more, but as you go along the length of the fin, the area gets decreased. And if you look at the cross section, it is like a triangle. Hence this kind of configuration is called as straight triangular fin. And since it is having a non-uniform cross section, so it is also referred as non-uniform fin. Okay, have a look at this again. It's a triangular non-uniform fin. Okay, again which is attached to the base surface. Now similarly, look at the third configuration. Here there is a cylindrical surface. You can see this, the hatch diagram. There is a cylindrical surface which is acting as a base surface, and from this surface again we want heat to be transferred. So for that, what is done here is, along the periphery of this cylindrical surface, we are going to use the extended surfaces, and it is in the form like a circular cross section. So this one is our fin, which is attached to the base surface, which is in the cylindrical form. I repeat again, the base surface is of cylindrical form, and surrounding to that base surface we are attaching the circular cross section fins. Sometimes they are also referred as annular fins. So these kind of fins we in general find in the applications of steam pipes. Okay, so to the surrounding to the steam pipe, we can attach annularly or circumferentially the fins over the pipes. Okay, so as to increase or decrease the heat transfer. Okay, so particularly fins, as we already know, they help in increasing the heat transfer. So annular fins are nothing but the fins which are having circular cross sections and being attached over the circumference of a given hard surface. Okay, so that is our third configuration. We call it as annular fins of circular cross section. Okay, now the last one, you can see here is again a base surface. Okay, maybe of some rectangular base surface, but look at the kind of extension what we have here. Okay, how is it? This particular fin is now, it is in the form of a cylinder. Correct? So cylindrical shape fins, if they are attached over a base surface, then that particular configuration of fins, they are referred as pin fins. They are referred as pin fins. So in our lab, what we have got an experiment on such kinds of pin fins. So there we will analyze a pin fin where we will study the performance of a given pin fin. So again, have a look at this fourth configuration. I repeat again, where see this pin fin is an extended surface where the fin is of cylindrical shape, which is attached to the base surface. Again, see this is uniform cross section. So cylindrical shape of uniform cross section being attached over the base surface. Okay, so such type of configurations are called as pin fins. So in most general applications, we come across these four different types of configurations. Okay, to quickly go through again, first one is called as a rectangular, you can see this, a rectangular cross section longitudinal fin. Okay, where the cross section is a rectangle and it is uniform throughout the length of the fin. Second one is a triangular fin of non-uniform area, and the third one is we call it as, this one is called as annular fins, because to the cylindrical base surface along the circumference the fins are being attached, which are in the form of circular area. So here the cross section of the fin will be circular. It can be triangular, it can be rectangular as well. So altogether they are called as annular fins. Annular here refers to what? It refers to the circumference of a given base surface. So to the base surface along its circumference, if you attach the fins, maybe of different cross sections, then that fins are called as annular fins. And the last one is called as pin fins. So here the specialty of this fin is, why it is called as pin fin means the fin which is attached to the base surface is in the form of a cylinder. You can see this is in the form of a cylinder, so having uniform cross section area, hence it is called as pin fin. So these are the four different configurations of fins that we will have to study, and out of this, for our syllabus we are going to study in detail about the first configuration called as longitudinal rectangular fin of uniform cross section. Okay, in my next session I'll be discussing about the analysis of the first configuration, that is a rectangular fin, where we will try to understand what is the rate of heat transfer through a rectangular fin, as well as the temperature distribution through a given rectangular fin. We are going to derive two expressions so as to understand both of these, that is rate of heat transfer as well as the temperature distribution, and that derivation is very important for the point of examination. Okay, thank you.